How do engineers test new space propulsion systems? Imagine trying to make a rocket engine that works perfectly in space. How do engineers make sure it will perform well in the harsh environment of space? Let's find out. Engineers start by checking every part of the propulsion system on the ground. They carefully inspect each component to make sure it's built correctly and all parts fit together. This step helps catch any manufacturing mistakes early. Once everything looks good, they assemble the engine and prepare it for testing. The next step is static testing. Here, engineers fire the engine in a controlled environment without moving the spacecraft. They use a special device called a thrust stand, which measures how much force the engine produces. This test shows if the engine can generate enough thrust and if there are any mechanical or combustion problems. To mimic space conditions, engineers put the engine inside vacuum chambers. These chambers remove air and create cold temperatures similar to what the engine will face in orbit. Testing in these chambers helps see how the engine reacts to near zero pressure and extreme cold. Another advanced method is hardware-in-the-loop testing. This involves connecting the actual engine to computer models that simulate how the spacecraft moves and responds. It allows engineers to see how the engine performs during different mission scenarios in real time. Engineers also use computer simulations called computational fluid dynamics and Monte Carlo analyses. These tools predict how the engine will behave with different uncertainties, like changes in fuel flow or environmental disturbances. This helps improve the design before doing physical tests. For electric propulsion systems, testing focuses on measuring thrust, efficiency, and heat management. These tests take place in specialized facilities that meet international standards for safety and reliability. Throughout testing, engineers monitor key parameters such as thrust output, fuel flow, pressure, temperature, and vibrations. They often do long-duration burns to see if the engine can run reliably over time. Finally, the entire propulsion system undergoes system-level certification testing. This comprehensive check verifies that the engine can handle propellant management, ignition, and microgravity conditions. Sometimes, engineers even use low-gravity aircraft flights to simulate space environments. All these steps make sure that new propulsion systems are ready for future space missions. They help confirm that engines will work safely and efficiently in the extreme conditions of space, paving the way for exploration and discovery.